Electricity feels instant. You switch on light on Nairobi, Kisumu, and Mombasa, and it turns on immediately. But behind that simple action is a vast and almost invisible chain of generators, transformers, and substations all working together. That huge connected system is the electrical grid. Today, we're going to unpack it as simple as possible using Kenya as our example. My name is Ken, and this is the African grid. To understand the grid, you only need to understand three stages: the generation, the transmission and distribution, and the consumption. Let's begin with the generation. Electricity is not created from nothing. A power plant converts another form of energy into electrical energy. I made a separate video explaining them in more detail, but here we're going to keep it simple. That energy can actually come from water, underground heat, wind, sunlight, or fuel. There are two broad families of generations. In the first, something spins a generator. Water does it in a hydropower plant. Steam does it in geothermal, thermal, and nuclear plants. Wind does it in a wind turbine. The primary energy source changes, but the basic idea remains the same. Something causes a rotation, and that rotation drives a generator, which in turn generates electricity. In the second family, electricity reaches the grid through power electronics. Solar panels convert sunlight directly into electricity. An inverter then prepares that electricity for the grid. Many modern wind turbines also use converters. Kenya's grid is supplied by geothermal, hydropower, wind, solar, thermal generation, and imported electricity. But geothermal stands out. It provides around 40% of the electricity generated in Kenya. At places such as Olkaria, wheels bring hot fuels and steam to the surface. That steam spins a turbine, which drives a generator. Now that you understand the first part of the electricity journey, let's move on to the second part, which is the transmission and distribution. Olkaria, like many other power plants, is far from home, office, and factories. So the electricity has to travel to where it is needed. Here's how it works. When electricity leaves a generator or an inverter, it encounters a particularly useful machine, a transformer. In a wind turbine, the transformer may be located inside the turbine or near its base. At solar park, transformers are installed at dedicated points close to the panels. And this remains true for hydropower plants, where transformers are located near to powerhouses. This machine serves one but important purpose. It raises the voltage. But why raise voltage? The reason is very simple. Because a high voltage allows large amount of electricity to travel long distance with less loss of energy in form of heat. But once this is done, we face another challenge. A line cannot run directly from every power plant transformers to every consumer. So the line must first meet and then properly get connected to the entire system. That happens in substations. You can think of a substation as a major junction point in the grid. It connects the different power lines and directs electricity along different roads. But also very important, it changes the voltage level. The substation's transformers increase or decrease the voltage, depending on whether it's close to a power plant or a specific consumer. From highest to lowest, Kenya's system uses different voltage level. At the top is the 500 kilowatt high voltage direct current interconnector between Ethiopia and Kenya. The main AC transmission network uses 400, 220, and 133 kilovolts. The voltage is then reduced to 66, 33, and 11 kilovolts as electricity moves into the distribution network. Finally, low voltage consumers receive electricity at 450 or 240 volts. And all this happening at the frequency of 50 Hz. This means that the alternative current completes 50 cycles every second. You now know how electricity is produced and transported. Let's now look at the consumption. In fact, not every consumer needs the same amount of power. Some consumers, such as large industries, manufacturing plants, and steel factories, are connected directly at medium or high voltage depending on their power needs. Right at the end of the chain, with much lower individual demand, are you, your home with hospital, schools, office, shops, water pumps, small or big businesses, and large industries. Together you make up the consumption side of the grid. In Kenya, the largest concentration of electricity consumption is around Nairobi. Other important centers include Mombasa, Athi River, Kisumu, Nakuru, Eldoret, and Thika. So we are done. You now understand how a grid works. See us in the next video. No, we are not done yet. But to conclude this video, let's have a look on the different institutions that manage the different stages of the Kenyan electricity system. At the generation, we have KenGen. It operates major geothermal and hydropower plants. Independent power producers also operate wind, solar, geothermal and thermal plants. The Geothermal Development Company develops geothermal resources and steam fields. For the transmission and distribution, we have KTRACO. It manages much of the high-voltage transmission grid. On the other hand, Kenya Power distributes electricity, connects customers, and manages matters. For the regulation, we have EPRA. It regulates the sector, including licensing, tariffs, and technical requirements. Each institution has a different role, but the entire system works as one. Now return to your light you switched on at the beginning. The electricity may have started as steam beneath the Rift Valley. That steam spun a turbine. A turbine drove a generator. Electricity gets generated. The voltage got increased by a transformer to minimize loss in form of heat. Then that power got sent to another set-up transformer located at a substation. From there on, transmission line carried that power across the entire country at different voltage level. And when it reached your neighborhood, another transformer lowered the voltage so it is safe for you and your appliances. Yeah, all of this happened silently every time you switch on light. And the fact that you rarely notice that this is all happening in background is in a way the proof that it works. Hopefully, you now understand the basic idea behind the electricity grid. If you do, tell me one thing you learned in the comments. Watch this video next, you might be interested. And of course, subscribe and share if you gain value from this video. It was Ken. See you in the next video.